Hi, good morning, everyone. I hope you can hear me well. Excellent. Okay, welcome to Gemini's Crypto 201 webinar, and we are very excited to have you join us this morning, if you're joining us here in Asia. My name is Jeremy Ng, and I'm the Managing Director of Gemini APAC, responsible for developing our business here throughout the Asia-Pacific region. And I've joined the company actually not that long ago, back in June. I'm very happy to be the first hire. And essentially, we're very committed to Asia, and we're using Singapore as our headquarters to launch out our offerings and solutions to investors and users in this region. So today's webinar is going to be hosted by Claire Novell, our Associate Director of Product Management, and also Matthew Werner, our Product Manager on our wallet team. So in this webinar, you're going to learn more about Bitcoin mining, Ethereum use cases, and also the future of cryptocurrencies. And at the end of the webinar, we're going to have some time for Q&A. So please feel free to drop on any of your questions on the Q&A window throughout this whole session, and we'll take it up at the end of it. So we're trying to schedule for about 45 minutes that we go through the materials, and we'll leave the last 15 minutes for a session that we can answer all the questions. So thank you very much, and I'll hand over to Claire and Matt.
Hi there, I'm Claire Lovell, Associate Director of Product at Gemini. I joined Gemini last October from Bread Wallet and have been working in blockchain and cryptocurrency for about 5 years. I run our retail products, which include our web and mobile exchanges, as well as our active trader platform. Matthew, why don't you introduce yourself?
Hi everyone, my name is Matthew Werner. I'm a product manager on the wallet team here at Gemini. I've spent most of my time here so far designing cold storage solutions to safely store large amounts of cryptocurrency. I've been in the industry for a bit over 4 years, previously working as the head of crypto engineering at Coinbase, and most recently I worked on an upcoming cryptocurrency protocol named Dfinity.
So today we're going to talk about the technical concepts behind cryptocurrencies, what a blockchain is and how a Bitcoin is created, what happens during the mining process, Ethereum ERC20 tokens and their use cases, and then we'll make some predictions on the future of cryptocurrency, and then we'll wrap up with some time for questions.
Okay, so to properly understand blockchains, we need to start by briefly discussing a concept in cryptography called a hashing function. It's some complicated math, but don't worry, we don't need to get too much in depth into it. All we really need to know is that a hashing function is a process you can run on any size of content, and it'll produce a unique identifier for that content. So, as you can see in this example, if you hashed a text file with these 4 names on it, you would get the 2C754 value on the right side. If you change, add, or remove any character in any of those names, the whole thing changes to a totally different value. This is some advanced cryptographic math, but we know that it works. The important concept to understand with this is that you can pass any data into it, and it produces a value that uniquely represents that data, and any other computer anywhere that hashes that same content will get this same unique value. So here you can see different batches of data, each producing different hashes. These batches aren't related to each other in any way. We just know that the contents of the batch, along with that hash, uniquely represent the data that is being hashed. So how can we make use of this hashing function in blockchains? Well, a key feature of a blockchain is that it's append only. You can only add to data that's already there. This prevents anyone from using the blockchain to rewrite history or change values in data that someone else added. This allows independent participants to share an open and permissionless database, the blockchain, trusting that the data, any data that they add, won't be tampered with by someone else. So this append-only functionality is enforced by requiring that any new content that's added must be added in a batch. Then that batch of data has to include the hashed value of the previous batch. We call each batch of data that we add a block. So this means that someone can't insert data into the middle of this chain or tamper with any of the data that's already been added. If that happened, the block coming after it wouldn't be referencing the correct hash. Remember, once you change any part of the content that's hashed, it produces a whole new value. In this example, we've linked these blocks together in a specific order, and now they're connected through a sequence of hash references. And if they were moved or changed in any way, the hashes of the data wouldn't be correct. When people use the term protocol, it means these are the rules that you need to follow in order to participate with this network. The rules we just discussed form the foundation of a blockchain protocol. Any computer that's interacting with this network follows these rules. This allows the computers to trust that their data is not going to be tampered with whenever they're using the blockchain. And this isn't a new technology. Blockchains were originally devised in 1991, but over the past decade, they've found their most prolific utility in cryptocurrencies.
So now that you understand what a blockchain is, let's talk about mining. So mining is how more Bitcoin is created. There are only ever going to be 21 million Bitcoin, so it's a deflationary currency. Mining allows new Bitcoin to be created up to that limit of 21 million. We won't hit that limit until 2140, but in the meantime, we're creating new Bitcoin all the time. The mining process is basically that you get a bunch of computer hardware together and they solve pretty complex mathematical computations, which are the hashing functions we just mentioned. Each time a problem is solved, they confirm a block or group of transactions. The reason that people are dedicating their hardware to doing that is they get block rewards, in other words, Bitcoin. So every block that's created needs to be confirmed by a network of those computers. These computers are all over the world and they operate in a decentralized fashion. They tend to be located where the cost of electricity is low to increase miners' profits, as that's usually the highest cost after equipment. Whoever has the most powerful hardware is going to get those computations solved and earn the block rewards. So a block is just a collection of transactions that are grouped together to be confirmed. There's a new block created about every 10 minutes, and each block represents a miner winning that reward. Right now, the reward is 12.5 Bitcoin. The halving, it's when block rewards are cut in half, which happens every 4 years. The last halving was just a few months ago, so in another 4 years, it'll cut in half again. That tends to change the incentives for miners, which leads to different miners entering and exiting the market. That can move the market price, which explains some of the excitement around the halving.
So let's talk about how this mining works in a little more detail. The cryptocurrency transaction is just structured data. It's like a paper check. You can have the to address, the from address, amount, stuff like that. So instead of the names as the data in our previous example, for what we put into the block, we can use the data that describes a set of transactions instead. So even if we have transaction data we want processed, how does our transaction actually get added to the blockchain? Well, each time a computer broadcasts a transaction, it's transmitted to a network to join a list of transactions waiting to be put into the next block. This list of transactions waiting to get into a block is called the mempool, or a memory pool. The pool of transactions kept in memory before being written to the blockchain. So anyone else that's connected to that network that wants to attempt to produce a block with those transactions can do so. They can make an attempt by running that hashing function over that transaction data. Those participants are called miners. to mine a block, they produce a hash with a specific set of data. So they take a set of transactions from the mempool, they run a hashing function on it, and they get that output. They take that set of transactions, the previous block's hash, and they add a random number to it. And that random number is just to produce a different hash with each try. The first miner to hash all those values together to produce a hash with a specific number of leading zeros at the start has found the next valid block. And you can see here in this example, if our protocol rules were to find a hash with one leading zero, using the number 4 for our random number allows us to produce what is considered a valid block. And the previous tries in 1, 2, and 3, those weren't considered valid because they didn't have that leading zero. We would let everyone else on the network know that we found it, and then proceed to work on the next set of transactions that are waiting in the mempool. To produce that block, we'd then use the hash of the block we just found as our reference, and so on. Once these transactions are found in a block, they're removed from the mempool, and this process is called mining. It's the way that your Bitcoin transaction gets processed without you knowing who's doing the processing. So the hashing process can take a lot of guesses. You try a lot of different random numbers. It's intentionally hard to find a hash with a lot of leading zeros. And in Bitcoin, they use a lot more than one leading zero. If it wasn't difficult to find a correct hash, it would be very confusing for miners to decide which valid block would be the next block to be added to the chain. The number of leading zeros required can be referenced as the difficulty of the network. And the difficulty will automatically adjust every 2 weeks or so, depending on how many people are trying, to make sure that blocks are usually produced every 10 minutes or so. When people say proof of work, it's in reference to this process of finding a hash that meets the rules of the protocol. We've proven that we've done the work required to produce a valid addition to the blockchain. The process of getting everyone to agree on what block should be added to the chain through these rules that we're talking about is referred to as consensus. And proof of work is Bitcoin's consensus mechanism. So why would people want to mine blocks? Running a computer costs energy and money. What's motivating people to process these transactions from a mempool for people that they don't even know? This is where the token comes into play. The same medium of exchange that sent in the transactions, Bitcoin, is being granted as a reward to the miner that found the block. If I decide that I want to run a computer that helps produce this append-only ledger of transactions, I'm rewarded with new Bitcoin minted out of thin air to pay me for providing that service to the people broadcasting transactions. As Claire mentioned, the halving is in reference to reducing these rewards by half. The rules of that the miners of Bitcoin adhere to state that over time, these rewards will decrease. This is to help control the inflation of the currency used as a medium of exchange. And some people find that event of enforcing this change to be an indicator of scarcity and like to speculate on the price of Bitcoin during such an event. You may have also heard of something called proof of stake. This is an alternative approach to Bitcoin's proof of work consensus mechanism. Instead of proving that you've done the work to produce a hash that meets the rules, everyone takes turns producing blocks to add to the blockchain, and their additions are expected to meet the rules. So in order to mine blocks in a proof of stake system, the miner needs to escrow a large balance of the reward currency in the network. They agree that if they do something that's against the rules, that escrow of funds will be slashed, and they'll lose the stake that they put forth to participate. All the other block producers check the blocks that are produced, and if any problems are found, the miner that identified the problem is rewarded for pointing it out. So proof of stake has less rules around what is considered a valid hash. It doesn't have to have the leading zeros. And so as a result, it requires a lot less work to find a correct one. This lets miners produce blocks faster and with less energy exerted by the computers doing the process. However, because the miners have escrowed funds, they're financially incentivized to follow the block production rules correctly. The intention is by behaving malicious nodes on the network, you're risking more funds than you stand to profit by the malicious behavior. And so people that are running nodes on the network aren't incentivized to behave badly. Proof of stake is a promising new consensus mechanism, which several cryptocurrencies make use of. And Ethereum is a cryptocurrency that's making plans to switch from proof of work to proof of stake. And Ethereum is a very interesting project that Claire can tell you more about.
So now that we've covered Bitcoin, let's talk about Ethereum. Ethereum and Ether were created in 2014, and essentially Ethereum is a new programming language built on top of blockchain technology. Ethereum is the blockchain and Ether is the currency or token. Ethereum was a big step forward in the cryptocurrency space because it creates programmable money. That programming is called a smart contract. I'll go into smart contracts in more detail in just a moment. One of the main things people built upon the Ethereum network are token-powered networks. Those tokens are called ERC20 tokens. ERC20 tokens are built in the Ethereum blockchain, but have their own ledgers to record the transactions. Many of the ERC20 tokens have unique use cases. Let's talk about a few of those. The Bitcoin blockchain is built for sending money between people. Ethereum can do that too, but it was built to run whole computer programs inside the blockchain that can move money around or even hold on to money. Those programs are, again, called smart contracts, and the easiest way to understand why they're so innovative is with an example. Let's say your firm agreed to invest in a startup if they met their year's revenue goals. You could set up a smart contract that would automatically release the payment if the goal was met without needing to involve your bank or their due diligence. The smart contract would monitor the startup's progress towards the revenue goal programmatically and automatically send the funds to their wallet once the goal was met. You can even release just a portion of the funds if they come within a certain percentage of their goal. That's just one example of what can be done with smart contracts. You can also use smart contracts to track who owns property, collectibles, or artwork. In fact, there's even a burgeoning digital art market in NFTs, which stands for non-fungible tokens, and are also called ERC721 tokens. NFTs are blockchain powered in order to ascribe provenance and rarity to the artwork. Gemini's own Nifty Gateway actually recently broke the auction record for an NFT with the sale of a piece called Picasso's Bull, which went for more than $50,000. One interesting thing that ERC20 tokens have been used for is to create stablecoins. Stablecoins are tokens with a value pegged to a fiat currency. A lot of people use these for trading to achieve liquidity without off-ramping fees, but there's many other use cases for them. For example, there's a number of governments that are thinking about creating digital dollars. Venezuela has gone so far as to actually create one called the Petro, but it has failed to achieve adoption. China and Russia's governments have both announced that they are creating digital versions of their currencies. I personally believe that one day in the future, the US dollar will be tokenized as well, and you'll have a way of digitally interacting with dollars without needing to involve the legacy financial system. BAT, or the Basic Attention Token, was created to allow users to be paid for their time viewing ads. It was created by Brendan Eich, the co-founder of Mozilla and Firefox, who now runs the Brave software company. Brave created an open source web browser that gives users privacy. It incentivizes a different digital attention economy than the current model dominated by Google and Facebook. Rather than suck up all your data, users can instead pay small amounts of money to content creators using the Brave browser. They can also be rewarded in the BAT token for any ads they do choose to view, so advertisers can still reach this audience and users can be paid for their time while maintaining their privacy. OXT, the Orcid protocol token, powers a decentralized peer-to-peer VPN. Bandwidth is payable in OXT and allows users to buy bandwidth from a global pool of providers. The token allows users to make cost-efficient micropayments for bandwidth by amortizing fees across many transactions. The main feature of a VPN is privacy. However, a lot of VPN providers take your data and resell it. Orcid doesn't track you or sell your data, so it's a superior provider to many others. Link is the token powering the Chainlink network. Today, most cryptocurrency businesses rely on centralized oracles to provide data to and from smart contracts. This requires software providers to trust that the oracles are providing accurate data. However, Chainlink is a decentralized oracle network, and they're able to provide real-world data to smart contracts on the blockchain in a decentralized and trustless way. So Link is a digital asset that is used to pay for services on that network. All in all, I think ERC20 tokens have a lot of promise, and I believe will be a strong part of the future of cryptocurrencies. What is the future of the crypto ecosystem? What does the future hold? So today, trading is a large part of that ecosystem. However, currency will go digital like everything else. And in that world, there will likely be less volatility in this asset class. Trading will be less speculative, although I do think that this is many years away. The most important thing to grow the value of this asset class is to increase consumer adoption by making crypto simpler to interact with and solving real problems for users. For example, DeFi, or decentralized finance, uses smart contracts to replace a lot of the functionality offered by banks that aren't serving customers very well today. In a world where bank interest rates are less than 0.5%, you can instead put your savings in a DeFi provider who can give you 5 or 10% interest. Over the next few years, I think there'll be a trend of replacing costly middlemen with smart contracts that can perform the same function more inexpensively to users and suppliers. For example, why pay a large portion of my driving wages to Uber when instead I could use a smart contract to match a verified user to a verified driver? Drivers would retain more of their wages, incentivizing an increase in supply, which would allow users to pay less for rides. Decentralized applications like these are called dApps. There are also use cases for things you want a permanent public record of, like your diploma or ownership of assets. For example, tracking who owns a car would allow manufacturers to notify even secondary owners of recalls and upgrades available. This is a nascent space, and there'll be many new use cases invented by the rising digitally native generations. So I hope you had fun and you learned a little something, and now we're ready to take some questions.
There's one question here. Why only 21 million of supply on Bitcoin, and who essentially sets that limit?
That's a good question. So 21 million was the original number devised in Bitcoin's white paper by the pseudonymous Satoshi Nakamoto. It could have been more, it could have been less. Other cryptocurrencies have a larger or smaller supply, but this was set to 21 million at its inception, and the halving of the block rewards since then are on schedule so that it should be down to 0 block rewards in 2040. And I see the other question there that, yes, I think the script is a bit outdated. It is at 6.25 now.
Thank you, Matt. And there's also another question relating to security. Someone talks about data breaches and stolen Bitcoins. And the question is, how is the cryptocurrency industry adapting to all these kind of emerging threats? and what has been implemented industry-wide, when it comes to cybersecurity protections to prevent, some of these malicious attacks?
Yeah, there are a lot of new advancements. A lot of the advancements are being made on the cryptography side of things. So originally, there wasn't a lot of best practices around protecting your private keys that allow you to broadcast transactions. And now we're seeing a lot better, really high security systems like we have at Gemini for our cold storage, where the keys that are generated have never been online. So you can't hack a computer and get access to it. It's never touched a computer that's connected to the internet. That's some of the good developments that's happened in the past 5-10 years. And now we're seeing some new interesting cryptography approaches where they have things like threshold signing, which is a different cryptographic approach so that you can authorize a transaction and the key has never been assembled. You just use different parts of it and they assemble together on the transaction. So the key actually never exists in its entirety, which is more secure. They're finding new ways to become more secure all the time.
So another related question is, how do we know that a transaction has not been tampered with one in the mempool?
So in the mempool, as we talked about, if I have a computer and I want to broadcast the transaction, I need to sign that transaction with the private key that I was talking about. And that private key needs to be authorized for the address that I'm broadcasting a transaction for. So if someone went into the mempool and modified the transaction, the signature of the transaction's data that was produced cryptographically by me using my private key on it wouldn't match the signature of the transaction. And it's similar to that hashing function thing. It's some advanced math that allows us to easily verify, yes, this thing came from the right place and no one has tampered with it.
I see another good question here. If fiat currency gets devalued, how will that affect stablecoins, and what advantages do stablecoins have over fiat dollars? So I think the thing that's important to remember about stablecoins is that they're digitally native, which is not true of dollars. So obviously, most of you are not in the United States, but here in the United States where I live, money moves very slowly. When our central bank literally takes several days to move money between large major banks in the United States, for example. So digital dollars allow you to move money in seconds for a very small amount of money. So I want to send Matt, whether I want to send Matt $1 billion or 5 cents, it doesn't actually matter. It's going to move just as quickly. Also, it's global, which for anyone who's tried to wire funds to people in other countries, it's very difficult to do that. It's time consuming, it's costly. So just having that, having the digital piece be actually baked into the dollar itself really allows you to make it completely borderless. You can send money to your family or what have you very easily. And the reason people, traders particularly prefer stable coins is when you trade out of cryptocurrency back into fiat dollars, sometimes you have to send that money to your bank account. Maybe you're paying extra fees depending on what crypto exchange you're using. Maybe you have to wait a couple days to get your money. Whereas if you're interacting with stable coins, you can keep your money kind of in the crypto ecosystem. And so you have that liquidity ready to go if you want to keep using it to trade. So if you want to react to the market very quickly, it's a way of having those dollars kind of ready in a reserve there. For you to keep interacting with them. It's also the main way people interact with a lot of smart contracts, because people don't necessarily want to put something like Bitcoin in a smart contract because I don't want to say to my Uber driver, right, in the example I gave, I don't want to say, here's a Bitcoin, and then tomorrow, today it's worth $5, tomorrow it's worth $10. I want to pay him $5 and know that it's still $5 tomorrow. And so stable coins are great for that. So even as the dollar changes, the value of a stable coin is going to change right with it. So it can just be pegged to whatever currency you want. Gemini has a GUSD, which is pegged to the US dollar value, but you could have it pegged to the Singapore dollar, what have you, anything you wanted basically. And it would just match that, pretty much 1-to-1 over time. So you wouldn't really have to worry about the fiat currencies, volatility. Obviously there are some cases where some currencies are much more volatile, but I don't think that's really been a negative issue for stablecoins.
I see another interesting question. And we all know that there's a maximum supply of 21 million of Bitcoin. So the question is, so what will happen when it hits 21 million? And we know that, roughly the expected time that we will have all 21 million mined is around like 2140. So what's going to happen to the whole blockchain?
Yeah,
after that?
I can take that one. So one of the things we left out in the explanation of taking transactions from the mempool is that in each of those transactions, a small portion of the Bitcoin that's being sent is allocated as a fee to the miner that finds the block. So this is usually, between a few cents to a few dollars, depending on how busy the network is. But basically the way that it works is that you create your transaction data, and then you earmark a set amount of a fee, a portion of the amount that you're sending, and then broadcast it to the mempool. And the miners can see all the transactions in the mempool, and they'll sort them by how much fee is allocated because they want to get the most money. So they'll take all the fees that are paying the highest, all the transactions that are paying the highest fee, put them at the top, and then try to make a block out of them. And when they find the block, they earn the block reward, and they get all of the fees of any transactions that are found in the block that they produced. So eventually, when we get all the way to the end of the block reward cycle, and the block rewards are removed, miners will only get the fees of those transactions. They won't get any newly minted Bitcoin. And that can still be motivating for a lot of miners. I think the economics will change for miners that it might not be economically feasible for them anymore. But the thinking is that the financial incentives for the miners will adjust, and the number of miners participating will adjust, and it will automatically scale to support whatever number of miners feel like they want to get a part of those fees.
Thank you very much, Matt. There's a question about when is Gemini opening a Singapore crypto exchange and office in Singapore? I'm very pleased to tell you that we are actually up and running here in Singapore. So we started about 6 months ago, and we have a team of 5 people now, and we're expanding that in the next 6 to 12 months to build up more support, more business development, and also to build up an engineering team. So we want to make sure that we are a full service office here in Singapore and servicing our Asia-based users and clients. And that's just the beginning. There is also plans that we're looking into, perhaps the Hong Kong, Australia markets.
So I think there's a question here about government control or takeover of cryptocurrency assets, and how safe is it to hold crypto, and how we can protect our crypto from being confiscated. So it definitely depends on the kind of cryptocurrency you're talking about, for one, because some cryptocurrencies, some digital currencies are actually decentralized, which means that no one actually controls them. And the only way for someone to take control of them is if they have access to your wallet. Just like if you have a physical wallet with cash in it, if I hand it over to Matt, he has my $20 now, right? And so if we imagine Matt is acting as the government and I hand him my wallet, yes, he can access those funds. But you know, if I take those funds and I bury them in my backyard and he doesn't know where they are, he wouldn't be able to access them. So with cryptocurrency, the difference is that you need the private key in order to access those funds. If you do not have the private key, you cannot take access. You cannot get access to them. However, a lot of people store their funds in a more centralized way. So for example, if you have your funds in an exchange and you don't custody them, you just leave them in the exchange hot wallet, they're safe from attack. However, if a government agency says to the exchange, you know, take this account and you need to deactivate it and we're gonna, you know, take those funds, right? The exchange, of course, is forced to comply because they obviously comply with regulations. So a lot of people prefer not to, you know, they either use a custody product like what we have at Gemini that Matt was talking about, like cold storage, you know, which is more security, though, again, you know, if there's government interference, obviously we have to work with regulatory authorities. But a lot of people choose a decentralized wallet. So you can have like a hardware wallet, like Nano, Ledger, Trezor. There's a bunch of different ones. You can have a decentralized software wallet, such as on your mobile phone. And in those cases, you are the only person who knows the key. You write down the key or you write down a passphrase that gives you access to the key. And unless people have that exact key or phrase, they wouldn't be able to access those funds. So I think, you know, just like you probably store your fiat dollars in a bank account and you know, as long as you're not breaking the law, right? You have pretty much full faith that your money's going to be there. I think, you know, the same rule pretty much applies here. I think at this point, the market cap of cryptocurrencies is so high and they're used so far and wide that it's really not at all, you know, it's practically impossible for any one government to say cryptocurrencies are not allowed anymore. They're not going to happen. You know, I know China has tried to do that a few times pretty unsuccessfully. So I think, you know, it's going to be here for a long time to come, and I'm not too concerned about that risk personally.
Yeah, I see a question here that says, how do we square the circle in what appears to be an ever-increasing amount of resources that are going to have to be used to mine ever-decreasing amounts of cryptocurrency? And this is a common question that gets brought up a lot with, you know, it's so intensive to mine cryptocurrency. And there's a few different things that, you know, are pretty good things to consider. One is that, you know, if you add up all of the costs of energy to power all the banks in the world, they use a lot of energy as well, and usually use a lot of computers to be transferring funds back and forth, and it's just distributed. It's not so focused on the production of blocks. And it's really been great to see across the world, there's been huge improvements on the efficiency of computers because the miners are really financially incentivized to drive the cost of electricity down. So one of the largest mining operations in the world is in Iceland, where it's positioned over geothermal energy, because they want to find a good, cheap source of energy to be able to produce mines at the highest profit possible. And lastly, earlier I alluded to proof of stake, where you don't need to go through that energy intensive process to find valid blocks. You are incentivized by the escrow of funds that you're putting into the network when you decide to become a validator, or they call it validators, but a miner on the proof of stake network. So we're seeing more and more networks choosing to go the proof of stake route. And in fact, I think Ethereum just had a big Ethereum 2 launch of their beacon chain yesterday, which provides proof of stake support. And I see another question here that, will Bitcoin ever move to proof of stake then, which is a great question. I don't know, maybe someday, but Bitcoin is very established in the original idea behind the white paper, and to move Bitcoin to proof of stake would be very difficult. And I think if it were to happen, it'll be a very long time from now.
Yeah, I mean, I think another kind of signal on that note is that Ethereum's journey to move to that system is taking them a pretty long time. The other thing I think that's important to note is that anytime a major change is made to a blockchain, the miners basically have to agree to make that change. Historically, that's very difficult on the Bitcoin blockchain to get people to agree to changes. People like the original Bitcoin blockchain the way it is for the most part. I think also to your previous point, I just wanted to add, the economic incentives for miners really push them to use greener methods because they're less expensive. If they have a cheap renewable power source, they're going to earn more because they'll have lower costs. So I think in that sense, it definitely helps reduce those costs there. But there was a question that I wanted to answer. Basically, someone was saying, Bitcoin has a limited supply, but many other cryptocurrencies do not really seem to have a very limited supply. How does that affect the value? So I think for most people, the thesis behind Bitcoin is often the fact that it does have that limited supply. It's a scarce asset that's going to grow increasingly scarce over time. A lot of people call it digital gold for that reason. And I think there's a lot of truth to that. I think for other currencies, you have to evaluate if they're powering a network or they have some other utility, because some of them, for example, if we think about Orcid, and I'm powering many millions of people's VPNs, and that token is helping you buy bandwidth on the VPN, doesn't really matter if there's an unlimited supply, because if they were using, dollars to trade that for bandwidth, wouldn't really matter that there was, basically an unlimited supply of dollars out there, right? So I think you just kind of have to apply that metric to each cryptocurrency and think about the actual purpose. Many ERC20 tokens are not really meant to be used as typical money. They're meant to be used as part of a network for a very specific purpose. And I think that's why their supplies are basically unlimited.
I see a good question here. What are the probabilities on accepting smart contracts as globally accepted by law? Are they currently adopted in any industry? This is a great question. I think it's still very early for them to be recognized as law. And there's an interesting governance question around a global blockchain and local jurisdiction of the laws that are interpreting those contracts. But there are some industries that are currently use these as legal contracts. There have been real estate properties that have been sold using the NFT standard that Claire mentioned in the webinar, where you can buy a portion of the ownership of a building, and your ownership of those cryptocurrencies that represent your share are legally binding. And there are case studies done on these houses that are being sold this way, and they found that it eliminated a lot of inefficiencies in the process of selling a home, especially in situations where you wanted to invest in the home, but you don't have enough money to buy the whole house. So there are some use cases in some industries where this type of technology is finding a use. And there's many more that have current organizations and projects being built to be able to serve a whole wide range of different types of implementations.
A similar question on the pretty hot topic on Ethereum 2.0. So can you explain a little bit more on that and what is changing, or why is that a leap forward?
I can take that one. So Ethereum 2.0 is something that had been worked on since late 2017. And it's mainly an effort to move to proof of stake to reduce the amount of energy requirement to find blocks, and to find a scaling solution to be able to support more transactions per second on the blockchain. So there's this overarching concern in the cryptocurrency industry of how do we scale these systems to process the same number of transactions as some of our highest throughput systems like credit cards or online payments. And there hasn't really been a lot of great answers in the past, but a trend that's kind of getting some traction is the idea of sharding. And you're essentially, when you're sharding a cryptocurrency network, is you're running multiple networks parallel to one another that are interconnected in important ways. So you might be on one cryptocurrency network that is compatible with an entirely different cryptocurrency network. And you don't need to be interacting with all of them, but if you're sending between those networks, or if you need to reconcile differences between them, they'll communicate with each other in a limited capacity. And so the thing that happened yesterday was the launch of the Beacon chain, which is the network that kind of ties them all together. And as they roll this out over the next couple of years, they're going to spin up more of these shards or separate networks that will be able to operate at a higher capacity for a smaller audience. And they'll be able to add more networks or more shards as their needs grow. And they'll all be tied together with the Beacon chain. And this approach to sharding is kind of the latest best stab by the industry to address the scaling solution or scaling problem. And this was probably one of the earliest ones. Was Cosmos did this. Lately, Polkadot and Avalanche are new cryptocurrencies that are taking the same model. And it's kind of an exciting time in cryptocurrency because there are multiple implementations of this approach, and it'll be really interesting to see what we learn about it.
I see there's a couple questions about future trends that I wanted to address a little bit as we wrap this up. I think that, you know, over time, right now, so much of cryptocurrencies value tends to be speculative trading, right? And, you know, people bought it at 3,000, now it's 20,000, right? And that's a great opportunity for a lot of traders and asset managers. I think that's really exciting for people, and it's been a great store of value. But is Bitcoin actually used as money today? Several people address this in their questions. You know, there's scalability problems with doing that. And I agree with them. I think Matt would say the same, that, you know, I don't personally believe that Bitcoin is necessarily going to be the medium of exchange, but I do think that we are going to need a digital currency in order to trade between, you know, over time, like commerce will be moving to a digital currency. Is that going to be Bitcoin? Probably not. You know, could it be something maybe built on top of Ethereum? Certainly. And I think there's, you know, there's so many applications for smart contracts that honestly we haven't even really thought of yet. But if you start actually thinking about some of these, for example, to go back to BAT for a second, you know, it's, if I want to read an article that Matt wrote, let's say, and I want to pay him 3 cents for doing that, it's completely impractical for either of us to do that. For him as a merchant, he has no way of accepting a credit card for an amount as small as that. For me, the fees on that transaction, you know, either to me or to him would, you know, would be much more than the 3 cents. So doesn't really make a lot of sense. And so many of our systems are set up in that way, where they're not, you know, infinitely divisible. They're not digitally native. They're not global, right? And so digital currency can address all of those. So I think over time, you know, yes, I certainly think the value of Bitcoin in particular will go up, but I think, you know, eventually we'll be in a world where trading is, you know, the price of Bitcoin is not trading that much, changing that much day to day rather, and it is much less volatile, and it's more, you know, more akin to the US dollar or something like that in terms of stability. And I think in that world, we'll be looking towards the actual intended purpose of digital currencies, which is to, you know, use them to actually exchange money. And I think that's where smart contracts will also add a lot of value because of that programmatic way. They can, basically monitor if something happened, then send money to here. So I think there's just a lot of potential there that we haven't seen. It's just very, very early in this space. You have to remember it was only invented in 2008. So still have a long way to go, I think.
Okay, there's a question that, there's a, what are the various ways to store, BTC, for example, or other coins after you purchase? And what are the more simpler way or the safest way to store them? So here I can, maybe I can share a little bit about our Gemini platform. So on our platform, you can obviously trade, you can buy and sell Bitcoin. But within the platform itself, you are also able to have a wallet to store your coins. So as an exchange account user, you automatically, once you sign up, you will be allocated a wallet, and that's where you can, hold all the coins that you trade. Now, if you want to have a segregated cold storage for yourself, then you can opt for the custody account. There's no additional onboarding. It's the same onboarding. It's pretty much a click of a button, a switch on or off. And when you opt for the custodian account, then you essentially will have a segregated personal wallet. So the difference between an exchange account or exchange wallet and a cold wallet is that on the exchange wallet, your tokens are essentially commingled in the pool. And within that commingled pool, the way that Gemini manages our liquidity is we'll leave a small portion of the coins or tokens on a hot wallet, around 5%. So the majority of exchange accounts users tokens are actually still stored within our cold storage or cold wallet, but it's just that it's not in a segregated manner. So if you want to really have your own personalized cold storage, then basically it will be the Gemini custody solution. Maybe we have time for one more question. I mean, there's an overwhelming list of questions that we have here, so I apologize if you're not able to answer every single one of them. So Claire and Matt, you want to pick one more question to address?
I saw one earlier that I liked. I'm not sure where it is now. Basically, the thought that how can we be so sure that these hashing functions are actually unbreakable, that they're unlimited secured? I know that that's like the natural tendency to think, well, there's got to be a way you can guess it, or you can break it, or run a computer against it and try to find it. But there's this, the way that the private keys are created in cryptography is basically this really elaborate math that uses enormous numbers, numbers that have hundreds of digits in them, and you have to combine two of them together in a specific way to find the next prime number that really is just impossible to guess. It's the kind of thing that, like, if you had to choose one atom out of the observable universe and you had to choose just the right one, it's like, yes, you technically could choose right, but for all intents and purposes, it's effectively impossible. I heard the analogy one time that like over the next 20 years, there will be a beaver somewhere on the planet that sneezes, and you have to guess what second he will sneeze. And yes, you could do that, but it's infeasible. And so when you say this is, protected and secure by cryptography, it really is. Like, you really can't break this. And I think the fact that there are, tens of billions of dollars available in cryptocurrency to steal if you could do this, and they haven't been stolen, just is a testament to how secure it really is.
Excellent. Well, mindful of the time, so thank you very much for joining us. If you want to learn more about crypto, there is a Gemini Learn on our website, and also please follow us on social media. We're on Twitter, Instagram, Facebook, and we also have a Telegram channel, Gemini Official _APAC. We'll send the link on the chat. And next week, we're gonna host another webinar on intro to Ethereum, so very specific on that that particular topic. So please join us and stay tuned. Once again, thank you very much for your participation, and we hope that you're gonna have a good day ahead. Thank you.
Thank you.
Bye.